Okay, section 6.5 is about solving open sentences involving absolute value. So the first thing we're going to do is just to refresh our memory as to what absolute value means. An absolute value refers to the distance on the number line between 0 and any other number. And we can also call 0 the origin. So anytime we talk about the origin of a number line, we're talking about 0. So if negative 5, if I want the absolute value of negative 5, that means how far from the origin, or from 0, is the number negative 5. Well, negative 5 is 5 units from the origin, so that's the absolute value of negative 5. What's the absolute value of 6? Well, how far away from the origin or from 0 is the number 6? It is 6 units. So when we talk about absolute value symbol, we're saying how far from 0 is this integer or fraction or whatever we're looking at. All right, so open sentences. There are 3 types of open sentences: equal to, less than, or greater than. And in this case, I'm looking for what possible values are 5 units from the origin. Well, let's draw a number line. If this is the origin, or 0, if I go 5 units to the right and 5 units to the left, these two numbers, negative 5 and 5, are both 5 units from the origin. So the absolute value of negative 5 equals 5, and the absolute value of 5 equals 5. So x can either be 5, the original value, or x can also be negative 5. What about less than 5 units from the origin? Again, if I look at my number line and find the spots that are 5 units from 0, then anything less than 5 units, meaning any number in here, which is closer to the origin than 5 or less than 5 units away, in other words, x is less than 5 and greater than negative 5, that would be the solution to this open sentence, because any value for x between negative 5 and 5 would have an absolute value or a distance of less than 5 units. What about greater than 5 units? So again, there's 0, there's 5 units away on either side. More than 5 units away means out here, further away from 0 than 5 units. Or in other words, x is greater than 5, or x is less than, to the left of, negative 5. Okay, so you notice that each of these solutions has 2 possible parts to it. An equation is either just the number as a positive or a negative. Less than is in between the 2 endpoints, and greater than is outside of the 2 endpoints. In other words, the absolute value symbol is a way to write, well, it's actually a shortcut to writing a 2-part solution. So this equation or inequality is the same as writing this 2-part inequality. Okay, we'll talk a little bit more about this in class, but I want you to see that a less than absolute value becomes an and inequality. Remember, we talked about 2 different kinds of compound inequalities. And a greater than absolute value expression becomes an or compound inequality. So just kind of keep that in mind and pay attention to that as we go through this lesson. So, solving absolute value equations. So when we had a simple equation of just the absolute value of x equaled a particular number, we could rewrite that by saying that x equaled the actual integer or x equaled the negative of the integer. Well, the same thing holds true when there's an expression inside of the absolute value. Whatever this expression is, that expression is either located, well, that expression is located 7 units from the origin, which means it's either at 7 or it's at -7. Okay, so again, the absolute value is a shortcut way of writing this two-part equation. So x equals 10 or x equals -4. So if I plug 10 back into this equation, the original absolute value, I get the absolute value of 10 minus 3 equals 7, which is true because 10 minus 3 is 7. If I plug -4 into here, I get the absolute value of -7 equals 7, which is also true. What about this one? Again, this entire expression is 4 units from 0. So what are the two numbers that are 4 units from 0? Well, it's 4 and -4. So this expression has to either equal 4 or the expression has to equal -4. Multiplying both sides by 3 and adding 2, I get that x equals 14. Multiplying both sides by 3 here, and then adding 2, I get that x equals -10. So again, two solutions always for a one-part equation. So let's think about this one again. I have two numbers, 10 and -4. Let's put them on the number line. So I have -4 and I have 10. Now, these two numbers, remember, are 7 units away. So let's go 7 units here. So from -4, 7 units to the right is 3. 7 units to the left is also 3. And you notice that if I take my number, x, and see how far it is from 3, the difference between x and 3 has to be 7 units. So, in other words, we can do this kind of problem in reverse. If I know my two endpoints or my two values and count how far they are, I can figure out my original equation. So let's do one of those. So here are my two numbers, 3 and 9. Those are what I want my solutions to be. X equals 3, x equals 9. And I want to write this two-part equation as an absolute value. Well, the midpoint of these two is 6, and both of these numbers are 3 units away. So the distance is 3. And what is my value of x? Well, it's the distance from 6. So x minus 6 equals 3 is the absolute value equation that represents these two numbers. And again, if we then worked this out, x minus 6 equals 3, x minus 6 equals -3, add 6 to both sides, I do in fact get the two numbers that I started with. And we will again look at this in class. Don't worry about this. Just get it down. Try to watch through maybe this a couple times so that it makes a little bit of sense. But let's go ahead and do our inequalities. Okay, remember with our basic one that the absolute value of x is less than some number. That means it's closer to the origin than n units, which means it's between n and -n. So that's our basic model for a less than absolute value. So again, this expression is less than 7 units. That means x plus 4 is less than 7, but greater than -7, or between 7 and -7. Subtract 4 from both sides. Remember, this is a two-part equation, so I have to subtract 4 from all of my pieces. Okay? So I'm subtracting 4, let me find my eraser, hold on, from all three pieces. So negative 11 is less than x, which is less than 3. So any number between negative 11 and 3 is less than 7 units away from negative 4. Okay, let's look at this one. Again, this whole expression is less than or equal to 12 units away. So 6 minus 3 minus x is less than or equal to 12, but greater than or equal to negative 12. Remember, I'm following this model for any less than inequality. So the middle part I need to do some work on. Negative 12 is less than or equal to 6. Remember, when we distribute that negative sign, it changes both of the signs. Now I'm going to combine my like terms. Negative 12 is less than or equal to 3 plus x. Now I've got to subtract 3 from all my pieces. Negative 12 minus 3 is negative 15. 12 minus 3 is 9. Okay? All right, let's try our greater thans. So again, remember back to our original model. If it's greater than n units, that means it's greater than n, or it's less than negative n. Further away from a point on the number line, meaning out here or out here. So again, using my model, 3x minus 2 is greater than or equal to 7, or 3x minus 2 is less than or equal to negative 7. Again, these two, since it's an or and it's two separate pieces, I solve them individually. Add 2 to both sides. Divide by 3. Add 2. And divide by 3. Okay, so that's my two-part solution to my absolute value. Remember what I said, every absolute value is a shortcut way of writing a two-part problem. Okay, so see if you can set up the next one on your own. Again, we're using the greater than model. So pause the video, try to set it up, and then check in and see if you did it right. Okay, so greater than 3 units away. So x minus 2 divided by 5 is greater than 3, or x minus 2 divided by 5, looking up here, is less than negative 3. Multiply both sides by 5, add 2, and same on this side, multiply both sides by 5, and add 2. All right, and that's our solution. So I think that'll be enough to get us going, and I'll see you in class.